Welcome, wonderful people. This is Mr. the Visitor, and this is the first tutorial that we're going to have on integration, and we just basically going to look at the basics. So for part one, guys, we will look at all this. We will solve 1, 2, 3, 4, 5 problems for part one, and then we will go to for part two, part three, and part four. So this is what we have for part one, together with the solutions to these integrals. So let me just copy down the first one. We want to find the integral of x squared sine 2x dx. This is what we want to find. Now what we need to do in here is the following. Right, we ask ourselves, are we going to use integration by parts or by substitution here? We need to use integration by parts, because if I make u be x squared using integration by substitution, I cannot get rid of that x because it's an angle. So because of that, you will require integration by parts. So there's something which they call the leate. They say you make if you have one of these in this order, you make it your u. So this is logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential. You make one of these in this order. So we have an algebraic function together with a trigonometric function, and because a comes before t, so we're going to make u x squared. It doesn't always apply, but we will see where it is applied. So like in this problem, so u equals x squared, and your du will be bring down minus 1 dx. So we're writing dx because we are differentiating u with respect to x. I will assume that you understand the differential calculus, and then from here I will also assume that you have the basics in integration. V prime will be the integral of whatever that is left, which is sine 2x dx, and then our v would be the integral of this. Now the first question that we ask ourselves is the following: what is the integral of sine? The integral of sine, it's negative cos. You hold the angle, then you differentiate your angle, you get 2. That 2 you divide it here, so you will get an answer of negative 1/2. So this is the same as negative 1/2 cos 2x. I will assume that you have the basics in algebra as well. So we have u, we have du, v, and v prime, so we can use integration by parts. Formula uv minus v du. Your u is x squared, your v minus 1/2 cos 2x minus 1/2 cos 2x times du. Your du is 2x dx. Fine. Then from here, what we can do, just rewrite this as minus 1/2 x squared cos 2x. Negative by negative is a positive. You have this as a numerator, and you have that as a you have this as a denominator and that as a numerator. You can't say this one because this is an angle, so this into this will go once, and then it's like you're having negative by negative is a positive, so you're having x cos 2x dx. That's what is left, x cos 2x dx. Let's check and see if this is true. Negative by negative, we said it's a positive. Good. This and this cancels. You are left with this and this and that. There it is. So we are correct. Now we started with this as an integral. We are ending with this. So the exponent was 2. Now the exponent is 1. So our choice of u was correct because this has to decrease at least by 1. Very good. So we're going to apply integration by parts the second time, but only working on this one. So I'm going to say looking at the integral of x cos 2x dx. Very good. So just as I made u in the previous one, u squared, I'm going to make ux. And du equals 1 times dx is dx. V prime is the integral of whatever that is left. And v is, what is the integral of cos? The integral of cos is sine. Hold on the angle. Differentiate the angle. It's 2. Divide by 2. This is the same as 1/2. Apply integration by parts. uv v du. U is x. V it's 1/2 sine 2x minus 1/2 sine 2x du. Your du is equals to dx. Rewrite this nicely. 1/2 x sine 2x. Factor this out. Minus 1/2 the integral of sine 2x dx. I know how to find the integral of this. 1/2 x sine 2x minus 1/2. The integral of this, you will say, what is the integral of sine? That is negative cos. Hold the angle, divide by 2, and this becomes like this. And you will have your 1/2 x sine 2x. Negative by negative is a positive. Remember, okay, let me just rewrite this nicely for you. So remember, we have 1/2 and we have 1/2 cos 2x. So remember what is happening here. Negative by negative is a positive, and this is 1/2. Can you see that? So I changed nothing there. So we have 1/2 x sine 2x plus 1 1/4 cos 2x. As an answer for this, remember we are set looking at this. So the integral of x cos 2x dx is equals to this. 1/2 x sine 2x plus 1 1/4 cos 2x. Right, but remember what we were solving. We had this and we just wanted to find that. So we need to add this to this, meaning we need to add this to this. So the integral of x squared sine 2x dx is equals to this minus 1/2 x squared cos 2x plus 1/2 x sine 2x plus 1 1/4 cos 2x plus the constant of integration. And this is exactly what they have here. Minus 1/2 x squared cos 2x plus 1/2 x sine 2x plus 1 1/4 cos 2x plus c. So the first one has been solved. We are fine with this one. Now we need to go to this one and see whether we will get this. So remember, we're just dealing with the basics of integration here, and we're going to mix integration by parts with integration by substitution depending on which problem we are working on. Right, let's try and look at the integral of x3 ln x dx. So I can work on this. Now the question is the following. I know I can differentiate this. I don't know the integral of this because I don't have it on the integral table, but I can integrate this. So I can integrate this and I can differentiate this. So u will be ln x du. The derivative of ln, it's 1 over x. V prime, it's whatever that is left. And what is the integral of this? I said I will assume you know the basics. This is 1 over 4x4. I'm sorry. uv minus v du. U is ln x times, so this is my u. My v, it's 1 over 4x4 minus 1 over 4 x4 times du 1 over x dx. And then I can just rewrite this nicely as 1 over 4 x4 ln x minus, I can factor out this, and I want you to see something here. When I factor this out, I have x4 divided by x1. If I cancel 1, I'll be left with 3. I hope you see that. I factored this out. 4, 1, cancel 1, you are left with 3 dx. 1 over 4 x4 ln x minus 1 over 4. I know the integral of this, it's 1 over 4 x4. So this is 1 over 4 x4 ln x minus 1 over 16 x4 plus c as the final answer for this. And this is exactly what they have in here. 1 over 4 x4 ln x minus 1 over 16 x4 plus c. So we are correct in what we are saying. Okay, remember we're dealing with the basics. And then from here, and these are just the problems that requires you to use integration. We are not dealing with word and scenario problems. We will do a tutorial where we're looking at all that. Right. Let's look at the integral of ex sine 2x dx. So how do we do this also? Okay, that's fine. I know that I can differentiate this and I can integrate this. We've been dealing with this. So u equals ex du equals ex dx, because the derivative of e to exponent x is e to exponent x. Okay, that is fine. V prime is whatever that is left, sine 2x dx, and v is the integral of this. Now I know that the integral of sine is negative cos. It's negative cos, hold the angle. Now divide by the angle. You differentiate the angle, you get 2, you divide by that 2, you'll get 1/2. Right, so apply the formula. Your u is ex, your v negative 1/2 cos 2x minus negative 1/2 cos 2x times du is ex dx. Very good. From here, write this nicely, minus 1/2 ex cos 2x. Negative by negative is a positive. You can't say this cancels this because this is an angle. Please be careful. So you're factoring this out and you are left with ex cos 2x dx. We started with ex sine and we're ending with ex cos. So we will need to do this the second time. So I'm going to say, looking at the integral of ex cos 2x dx, my u, it's still ex, and my du ex dx, v prime is now cos 2x dx, and v would be, what is the integral of cos? That is sine. Sine, hold the angle, 2x, differentiate the angle 2, divide by that 2. Very good. I hope we are following correctly, wonderful people. Now from here I can continue. So what I can do is to say, okay, uv minus v du, u it's ex, v it's 1/2 sine 2x minus 1/2 sine 2x times du. Du is ex dx. Very good. Rewrite nicely, 1/2 ex sine 2x factor this out, the integral of ex sine 2x dx. Now I want you to be aware of something here. I honestly need you to be aware. Now look what is happening here. We started with this, and look, we are ending with this. So what we need to do when we get here, we need to stop, and then we need to equate this with everything that we have found. Let me show you what we have found. Now remember, this is what we got, and we were busy just trying to look at this only. So what I'm going to do there is the following. I'm going to write this, which is minus 1/2 ex cos 2x plus 1/2, this 1/2, and I'm going to multiply this 1/2 with everything that I found there. What is this? We worked it all along and we found it to be this. So I'm going to write the whole of this here. 1/2 ex sine 2x minus 1/2 the integral of ex sine 2x dx. Very good. So I'm going to say minus 1/2 ex cos 2x plus 1/4 ex sine 2x minus 1/4 the integral of ex sine 2x dx, and the whole of this is equals to that. Remember, it's equals to the integral of ex sine 2x dx. That is what it is equals to. Now when I'm here, what is it that I can do? I can group the like terms, because this is the same as that, and this is minus 1/4. There's a 1 here, so this is the same as saying 1 plus 1/4, which is 5/4. So I'm going to say 5/4 the integral of ex sine 2x dx. I'm very sorry guys, I don't have enough space, and that is equals to all this, minus 1/2 ex cos 2x plus 1/4 ex sine 2x. Remember this one, I took it to the other side. So what I can do from here, I can divide everything by 5/4 in order to find that the integral of ex sine 2x dx is equals to, so I have minus 1/2. I'm going to multiply by the reciprocal of this, which is 4/5. This should give me negative 2/5. So I have negative 2/5 ex cos 2x plus, I have 1/4 by the reciprocal, this is 1/5 ex sine 2x plus c as the final answer for that. 1/5 ex sine 2x minus 2/5 ex cos 2x plus c. So we are very much correct. Now let's go to the fourth one. Let us go to the fourth one and see how far we can do this. Let me just flip the pages. So for this one, I'm not going to draw up a line because it will require some spacing. This one requires a lot of space. So what are we going to do this here? We have the integral of sec 5x dx. This is what we have. We need to integrate this. Now I know in the integral table, I know that sec squared x dx is 10x. So I'm going to rewrite this as the integral of sec squared x sec 3x dx, because when I multiply numbers of the same basis, I add the exponent. So I don't have a problem with this. Right. Secondly, what is it that I need to do here? So we are here, wonderful people. So after I have written this in this way, then what is it that I can do? I know the integral of this, so I can differentiate this one. So this is u, this is v prime. So my u is equals to, this can be rewritten as sec x to the exponent of 3. So that du, it's 3, hold on the angle, subtract 1, and then differentiate the inner angle. That will be sec x 10x dx. And my v prime will be the integral of sec squared x dx, and my v will be 10x. Now remember here, when you differentiate, you bring down, you hold the angle, you subtract 1, then you differentiate the angle. This is the chain rule. And then v prime, it's whatever that is left. We dealt with this, so this is what is left. The integral of this is that. So now I can apply integration by parts. So let me just do this. Very good. So what I can do from here is, okay, uv minus v du. My u obviously is this. I can rewrite this back as that. So sec 3x times v 10x minus v 10x du. I can rewrite this. I want you to be careful of something here. You have sec squared multiply by sec, that will give you sec 3. So you will have 3 sec 3x 10x dx. Very, very important that you realize this. And then from here I can try and multiply sec 3x 10x. I can factor out this 3. 10 multiplied by 10 is 10 squared x sec 3x dx. Very good. And then from here I can change 10 to be sec squared minus 1, so that I can only work with sec. So sec 3x 10x minus 3, the integral of sec squared x minus 1 multiplied by sec 3x dx. And I'm going to do this. So I can use distribution in order to get rid of the bracket. So I have this, which is sec 3x 10x minus 3, the integral. So multiply this with this, you will get sec 5x. This with this, you will get minus sec 3x dx, because remember this dx is to multiply everything here. This dx multiplies everything in here. Very important that you see this. Now when we are here, what is it that we can do? Okay, we can use distribution of minus 3 multiplying back there. So you have sec 3x 10x multiply here minus 3, the integral of sec 5x multiply with the dx. Negative by negative is a positive 3, the integral of sec 3x multiply also with dx. I hope you understand the algebra there. And because you do now, meaning sec, the integral of sec 5x dx is equals to this. Now this has been dealt with. I don't have a problem with this. I am trying to find this, so I can leave this and I will have to focus on this one. I don't know what this is, so I'm going to say looking at the integral of sec 3x dx. So let's leave this 3 for now, just work on this. So this, I can rewrite this, the integral of sec 3x dx as what? As sec squared x sec x dx. Why? Because I can integrate this and I can differentiate that. So the same thing that we did here, we're doing it here. And I want you to see the difference. It was a sec squared, sec 3. Now we're dealing with sec squared, sec x. So it has been decremented by 2. So what we can do here is, okay, u equals sec x, and du, what is the derivative of sec? That is sec x 10x dx. And v prime is whatever that is left, the integral of sec squared x dx, and my v, the integral of this is 10x. Okay, so let's apply the formula. U v du. U is sec x, v is 10x, 10x du, it's sec x 10x dx. I hope we are fine. So I can come here, because this multiplies by this is tan squared. So I'm having this sec x 10x minus the integral of tan squared x, because this times this is tan squared. I have my sec tan squared x sec x dx. Okay, I'm going to change this once again, which is also equals to sec x 10x minus the integral. Tan squared is sec squared x minus 1. This time it's multiplied by sec x dx, and this is the same as sec x 10x minus the integral, multiply out, you will get sec 3x minus sec x dx. Very, very important that we see this. So what we can do from there, from here, I can now use I can multiply by negative here and there. That's all what I need to do. So I'm going to come here, I'm having this sec x 10x, so I'm going to say minus times this would be minus the integral of sec 3x dx. Don't forget that this dx also multiplies this. Negative by negative is a positive. The integral of sec x dx. Now when I'm here, look what is happening now. I said I was trying to look for this, and look what I'm ending up with. I'm ending up with this. So meaning the integral of this, when I work it out and work it out and work it out, I find it to be equals to this. So what I'm going to say is the integral of sec 3x dx is equals to the whole of this, which is sec x 10x minus the integral of sec 3x dx plus, I know the integral of this. The integral of this is ln of the absolute value sec x plus 10x. So we have like terms. This is positive, this is negative. You take it to the other side, it's like we're having 1 plus 1, that gives you 2. So 2, the integral of sec 3x dx is equals to sec x 10x plus ln sec x plus 10x. And I can divide everything by 2. so that the integral of sec 3x dx is equals, there's a 1 here. If you divide by 2, you're going to get 1/2 sec x 10x plus, there's a 1, the same, len sec x plus 10x. So this is what it is equals to. Now remember what we were looking at. We were here. We now have this, which is equals to the whole of this, but we need to multiply the whole of this by 3. So I'm going to say, okay, this is equals, multiply this by 3, you get 3/2 sec x 10x, multiply by 3, 3/2 len sec x plus 10x. So this is what this is virtually equals to that. Now let's go and check. We had this, the integral of sec 5x dx, and we said that it is equals to the whole of this. And then I said, let's work out this first, and then we will come and put it here. So the integral of this is the whole of this, but this has already been dealt with. So let me write this, sec 3x 10x minus 3, the integral of sec 5x dx. So where I see this, I'm going to write the whole of this, plus 3/2 sec x 10x plus 3/2 len of the absolute value sec x plus 10x. Now look what is happening. You have this with a 1, you have this with minus 3. If you take it to the other side, that will be 1 plus 3, which is 4. So you're having 4 of this, and you divide everything by 4. So the integral of sec 5x dx is equals, there's a 1 there, you divide it by 4, 1/4 sec 3x 10x. Remember, this one went to the other side. So what happens if I divide by 4 here? You have 3 and this multiplied by the reciprocal of 4, which is 1/4. And that will give you 3/8. So you will have plus 3/8 sec x 10x, same number. So this is also 3/8 len of sec x plus 10x plus c, and that becomes your answer. That truly and honestly becomes an answer to this problem, and you are done. Right, that was a lengthy, very lengthy problem to deal with, and let's go to the very last one. And the last one is this. We want to find the integral of sine nx dx. So how do I do this? Now I can rewrite this as the integral of sine n minus 1x sine x dx, because when I multiply numbers of the same basis, I add the exponents. N minus 1 plus 1 is n. So I know the integral of this, and I can differentiate this. So u equals sine n minus 1x, so that du, remember to bring down n minus 1, hold the angle, sine x minus 1, n minus 2, because you'll say n minus 1 minus 1 is n minus 2. Now differentiate the angle. The derivative of sine is cos. The derivative of sine is cos. This is cos x dx. Very good. So v prime will be the integral of whatever that is left, and your v will be, what is the integral of sine? That is negative cos. Very good. So from there, what is it that we can do? We can apply integration by parts formula. uv minus v du. Your u is sine n minus 1x multiplied by v, which is negative cos, minus negative cos x times du. My du is the whole of this. It's n minus 1 sine of n minus 2x cos x dx. Okay, then from there, what is it that I can do? Now what I can do from here is the following. I can just rewrite this nicely as negative cos x sine n minus 1x, and then negative by negative is a positive. Remember, we said this is a number, take it out, n minus 1, and you are left with the integral. Look what is happening here. Cos times cos is cos squared sine of n minus 2x dx. Can you see this? We took this out. Negative by negative is a positive. Cos times cos is cos squared. You are left with all this. Now, where do we go from here? I can rewrite this as 1 minus sine squared, because I only want to be left with sine, not with sine and cos. Negative cos x sine of n minus 1x plus n minus 1, the integral. This can be written as 1 minus sine squared x sine n minus 2x dx. Very good. And then from here, negative cos x sine n minus 1x plus n minus 1 multiply, you'll find the integral of sine n minus 2x okay, that is fine. Let me just say dx. Immediately just multiply by that, and then this by this, positive by negative is a negative. Now look what is happening. When I multiply here, I add the exponents. 2 plus n minus 2, that is n. So you'll be left with minus sine nx dx, the integral. Remember, this times this times this is this, the integral of this. Now what did I forget here? N minus 1, because it's like, okay, let me not do it in this way, because I think I'm going to confuse you now, and I never and ever want to confuse you. Let me show you what I'm doing. I'm having negative cos x sine of n minus 1x plus n minus 1. Good. Now look what is happening, the integral. Okay, let me say this times this is sine n minus 2x. Very good. Positive by negative is a negative. Multiply here, you know that you will get sine nx dx. Right. So this n minus 1 and the integral together with dx multiplies here and here. This is what I'm trying to do. Negative cos x sine n minus 1x plus, now this multiplied by this, you will get n minus 1, the integral of sine n minus 2x dx multiplied by that. Positive times negative is negative. N minus 1, the integral of sine nx dx. Very important. Now when we are here, we're going to stop. Why are we going to stop? Because I started with this and I'm ending with this, and we know how to do that. Now this is equals to the whole of this, you remember. So the integral of sine nx dx is equals to minus cos x sine of n minus 1x plus n minus 1, the integral of sine n minus 2x dx minus n minus 1, the integral of sine nx dx. This is what we have. And now look what is going to transpire here. This is positive. It's like we're having 1 here. And this is negative. So when you take this to the other side, it becomes positive. I'm going to do this step by step. So we have this. Take that one, you will have positive n minus 1 sine nx dx. That is equals to this negative cos x sine of n minus 1 x plus n minus 1, the integral of sine n minus 2x dx, because this one has went to the other side. So you have a 1 here. Now look what is happening. You're having 1 plus n minus 1. So 1 and 1 cancels. You are left with n. So you're having n, the integral of sine nx dx. That is equals to this. Minus cos x sine n minus 1x plus n minus 1, the integral of sine n minus 2x dx. Divide everything by n, so this is equals to minus 1 over n cos x sine of n minus 1x plus divide this by n minus 1 over n, the integral of sine n minus 2x dx. So that what is this? This is what that is equals to. So it is equals to minus 1 over n cos x sine of n minus 1 plus n minus 1 over n, the integral of sine n minus 2x dx. And you are done for part 1.